Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today I'm excited to welcome Jon Reid. Jon, thank you so much for joining us.
Thank you for having me. It's great to be here. So for folks who don't know me, I am an iOS developer who happens to be what we used to call in the old days test infected. Test infected means that at a certain point in my career, I was coding without writing unit tests for a long time. And then I came into the world of unit testing and it infected me. It changed how I think, how I operate, and pretty much turned everything upside down. And from then on, I've been dedicated TDDer, test-driven development, and sort of a voice, maybe. I don't want to call myself, give myself a grand title, but I think of myself in a way as sort of one of a few, not many voices in the iOS world. I know that in other parts of the tech community, people are more familiar with unit testing, and less so in the iOS world. And so I started a consultancy, Quality Coding, in which I offer training and coaching to companies around the world to help their iOS teams come up to the next level, to improve their ability to do unit testing and TDD and refactoring and just tightening their feedback loops so that they can operate more efficiently. And as part of that, I ended up writing a book, which I never thought I would do. And oh, what a lot of work, but a pleasure once it's done. My book is iOS Unit Testing by Example, XCTest Tips and Techniques Using Swift. So that's been my world in a nutshell.
Great. Prior to starting to record, I was bragging how I'm coming from Rails in the Ruby world and community, and how TDD and BDD are widespread there, or at least that's how we brag.
At least much stronger, for sure. And I've learned most of my TDD, well, first from sort of the original folks, but then a lot of what I learned comes from the Java folks and also the Ruby community. I'm not like a super genius or anything. I'm just taking ideas I've learned from elsewhere, and I tried then to apply them to iOS work.
Yeah. Well, as you said previously, that you don't want to kind of brag, but you are a voice of like promoting those good practices in your community. I would say that that spark needs to come, and a few good materials need to appear in the community. So I myself am not an iOS developer. I don't know if this is the first book which is promoting unit testing in the community, but it's certainly very important, especially for the people who are new to the area. Because what are the defaults when I want to become iOS developer? What are these 3 books that I should look into, and who are the people that I should follow?
Well, I assume, like in the Ruby world, that testing, at least unit testing, we'll leave TDD out of it for now, but unit testing is probably part of sort of the core, you might say, curriculum, the things that people learn as they are learning Ruby is like, oh, and you want to be able to write tests. Yes. And it probably comes a little more naturally than it does for folks in the Apple world.
I would say for the Ruby world and community, Ruby on Rails as a framework was a driving force behind, Ruby adoption in general. And I would say that along with that framework, as, testing framework was set up by default. And whatever you took like shortcuts to, generate some scaffolds around, you always got those tests, let's say for free. They were auto-generated, but it was more of a framework which kind of brought that by default, which is not the single force that drove that, but is one of the forces. Yeah, I don't know how is that for the iOS world, because it has quite a long history. I mean, in the beginning, all iOS apps were developed in Objective-C, which is quite an old language and software stack.
Yes, it is. I think that actually having its roots in Objective-C was what made so much unit testing possible and much easier to do because it's a fully dynamic language that if you want to swap out a troublesome dependency, it was easy. And there are various tools. I wrote some tools to help folks do that in as you said, an old language. It's 30 years old, so it has a lot of history, and coming out of the small talk world, fully object-oriented, except, of course, for the C part. That's where Apple, when they announced the Swift programming language, the catchphrase they used was that it was Objective-C without the C, which, in some ways it is. In other ways, it is quite a different world and more strict. Some things about that strictness are helpful around type checking. Other things are less helpful, but it's never stopped me from unit testing. I mean, I was doing unit testing long before iOS came around, so it just seemed natural to continue.
Hey everyone! Semaphore has published an open source book called CI/CD with Docker and Kubernetes. It combines just the right amount of best practices and practical advice for shipping cloud-native apps. Download your free copy today at semaphoreCI.com. On that point of doing unit testing, you mentioned something in the prep call around a team being fired.
Okay, so my story is that when I started coding, for the longest time, I was actually just sort of the solo coder at a non-coding place. We need a program. And so I'd be like, I can write program. I had no idea how to work on a team or what big projects were like until I moved to Silicon Valley. And one of my early jobs, I worked at a large company, and our team was working on a piece of software that none of us had actually were part of writing. It was inherited code that was a patchwork mess because there was exceptions for this and that and all sorts of things with no clear guidance around it and no tests, which meant that there were parts of the code that we were comfortable with, but there were definitely parts that we were scared to touch because we knew that if we changed anything in this one section of code, things broke. But we wouldn't know right away that they broke. It was a tool for other programmers in the company. We'd have to basically ship our code, so to speak, to the other programmers, and then they would complain and say things were broken. So that was a very long feedback loop for us. And it was frustrating. And in the context of that frustration, that's why I started to learn about unit testing. Actually, our whole team became desperate. We were like, there's got to be a better way. It was stressful. So I started to learn about a few things. One was design patterns. The design patterns book from the Gang of Four had come out probably a few years prior to that. And so I found that and I thought, this looks interesting as a way of guiding us. This was all in C++. So somebody else on the team led us to the Effective C++ books, which offer various patterns or tips for things to do and things to avoid. Sort of where are the traps? So those things were helpful. But as I wanted to learn and research more about design patterns, I went looking on the web and came across this site called c2.com. It is the home of the original wiki. And the wiki was created as a way to have discussions. Wikis kind of get a bad name now, but the whole point was to have a conversation, not like documentation so much. And there were conversations about design patterns. There were also conversations about this other thing called extreme programming. And I was like, what is this? This looks really interesting. And as I got into learning about extreme programming, I learned that one of its sort of core features was feedback loops. Lots and lots and lots of feedback loops. How can you get them more? How can you know whether the last step you took was successful or not? Which, of course, leads into CI. That was another thing that was born out of extreme programming. And so I became very interested in this. We started to learn about it, but it was kind of too late because the company was frustrated with our lack of ability to maintain this piece of code, and we were basically all fired. So it was a stressful time. And my hope is that by teaching people how to do TDD and especially how to do refactoring, which is a big part of test-driven development. I really want to help people have less stress in their lives, to be able to sleep better at night, to be able to work normal hours without doing overtime. And so that's sort of my journey of how I got into all this in the first place. And it does intersect with CI. How about that? That's definitely, a cornerstone, one of the feedback mechanisms that is very important for how a modern programmer ought to be able to work.
Generally, when we are talking with teams and trying to help out to either, embrace the practice or to push it to the next level, it's all about the speed of a feedback loop and removing risk. And by removing risk, also removing stress for people when they need to ship their software. Numbers here play, I think, a vital role. We are advocating that your feedback loop on your test unit suite should be like under 10 minutes. Dave Farley, the author of Continuous Delivery book, I think that he pushes for 5 minutes. We try to be maybe a bit more realistic, what matches the majority of teams.
That would be challenging for an iOS project because it's a couple things. One is that it's fully compiled. So before you run tests, you have to build the thing. And that takes time in itself. But Objective-C is a very simple language. You have objects that send messages to objects, and that's basically it. Swift has a lot more intricacy and complexity to it, and that means that the build time just takes longer. Every iOS programmer is familiar with this. So yeah, you have to factor that in. One key difference in how CI feedback differs from the TDD cycle is that in TDD, you would be working with incremental builds. That is, you would keep most of your object files, your compiled files, the same, but only rebuild the one thing that you changed and maybe anything that depends on it to try to get the feedback as fast as possible. But in CI, as you know, you don't want to do that. You want to start from a nice, clean, safe starting point that's predictable so that your results are predictable. And if it takes a little longer, yeah, I'm with you. I will dream with Dave, but I must live in the world I live in.
Yeah, it's a bit different when the keyboard is under your fingers and you're refactoring something, changing a single object or a function. You want to get something in a couple of seconds and continue your thought process straight away. But as a feedback loop for the team, the CI is what comes into place. Depending with whom I talk to, but sometimes I explain CI as like a communication tool for the whole team.
I like that.
Yeah, there is something which is shining there, which is either green or red, and it communicates to the whole team, okay, in what state we are. Even if it's our master branch or any other branch, we kind of know where we stand.
Now, one thing about iOS work and automated testing in iOS is that while projects that you create in Xcode by default come with various testing abilities built into it, I think that unit testing is still underused. It is underexplored. People tend to fall back on what they call UI tests, which are fully sort of integrated tests that poke the system through the user interface without changing anything else about it. Like you take your whole app as it is, and you don't get to change anything in there. You just have to run your app, which conceptually sounds easy. It's easy to understand that, oh, yeah, it's like somebody using your app. The problem is that when people use that as sort of their main testing mechanism, it's slow for starters. If you think about how you want to test a particular screen, that to get to that screen, first you must launch the app, then you have to most likely log in, right? And then you have to navigate to that screen, tap, 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 and all these things. There are tricks to speed up the transitions and so forth, but it takes a while just to get to the screen you want to test. And even once you're there, comes with the built-in dependencies. It's not easy to replace things with fakes. And that's the real strength of unit testing, and where I would encourage any iOS folks listening, most of what you want to do, you can do with unit tests. There are tricks, which is why I wrote my book. But the benefit is that your tests are so much faster and they're more robust and they're more reliable. They don't break as often. And so you get the faster feedback. Even your CI feedback will be faster if you lean more towards unit tests and have fewer UI tests.
Hey, I'm going to take a quick break here and tell you that Semaphore has a new book out called CI/CD with Docker and Kubernetes. If you are looking to deploy cloud-native apps, it's going to show you the most productive way of doing that. And the best of all, it's free. Download your free copy today at semaphoreCI.com. That balance is something you for sure know about is that testing pyramid.
Oh, yeah.
And keeping that in balance is very important. If we add also like time as a variable here, so let's say our most interesting customers to talk to and to help them resolve their problems are teams who have successful apps that are roughly 10 years old. As you can imagine, over the 10-year period, a lot of test suites accumulates. And if that testing pyramid is not respected, or maybe, there is just internal culture, let's just kind of copy paste that previous, let's call it integration tests, which in web world would mean, you need the database, which is writing to the hard drive. You need your app server to run. You need your browser, hold the JavaScript step in your browser. And it goes all the way, from the top to the bottom, entire stack. It is very slow. Also, those tests, as you said, break more often and can be also flaky. I'm not sure if that's one of the attributes of tests in iOS world.
Yes, it is.
Yeah. Unfortunately, there are animations, there are network calls, this and that, some various timeouts. And you can end up being in a pretty bad position. Having a test suite that takes, 2 hours to run, even more, with a lot of all those flaky tests. And in those situations, there are, certain things that you can do with, let's say, money. You can parallelize a lot. But what you cannot do, you cannot eliminate those flaky tests easily. And there is a significant engineering investment that has to go in, sometimes taking months to weed out all those flaky tests. And all that could have been, much better if a couple of years prior to this, someone would be advocating for write more unit tests and have a few of those heavy integration tests. Don't you overuse them?
I think what a lot of people don't understand about the testing pyramid and the reason it's shaped the way it is it's not just sort of like a catalog of different types of tests you can write with sort of lower level ones at the bottom, and the higher you go, more integrated they become. It's that the shape is wide at the bottom and skinny at the top, meaning that you should have many unit tests, low-level tests, and the higher your tests go in terms of integration, the fewer you should have until finally maybe you have just a handful of tests that exercise your system fully end-to-end.
Yeah. Something that I want to ask, there are various teams in their different stages of their lives, and some invest in, let's say, eliminating those tests in the top, because after a while, you can figure out that, this test hasn't been broken in maybe 2 years, because it's testing something, whatever the feature it is, but maybe we don't need it anymore. Maybe it's doing us more harm than good. Maybe it can be converted to unit test or to something in between, which is just touching fewer components. So what I'm interested in hearing is what is your experience in terms of investing in maintenance of the test suite?
Sort of to balance what I said, just to be clear, I'm not advocating not writing integrated UI-driven tests. They are important. And there are ways to write those that are less fragile. Folks in the web world know about page objects. In iOS world, that's less familiar. Basically, it's another layer of abstraction you write so that instead of saying, find the button with this label and tap it, instead you turn that into a command so that if anything about the label or the button changes, you only have to change it in one place. So there are ways to make your integrated tests less fragile, I've gotten essentially to where I am by concentrating solely on unit tests. I'm writing UI tests now for the first time in my career. This may shock some people, but the reason I haven't had to is because I haven't felt the need to, because I have had such confidence in the unit tests that I write. And I think that for folks in the Apple ecosystem in particular, the great barrier to unit testing is not understanding which dependencies create problems for testing. You mentioned networking, for example, that there ought to be some way of saying, let's not talk to the real network. Let's talk to this fake thing that's going to return a fake response, or maybe even just stop and capture the request and say, here's the request, you can look at it. So there are various types of things, anything that's slow. I took an idea about unit testing called the first tests, and I took the first three letters, FIR, and added an E on the end to think about for fire, FIRE, what are the dependencies that cause problems, or the ones that don't? If they are fast, then it's probably pretty good. If they are isolated, that is, they don't create any side effects that will cause problems for tests coming after it. Maybe this test is fine, but you've now altered the global state in some way. If it's isolated, it's fine. If it's repeatable, time is another one. Anything that operates with dates, isolate it. Find a way to not talk directly to the system clock. Instead, talk to an abstraction so that you can test, say, with any times you want to test with. And the last is easy. What I mean by that is that there are certain APIs where if you call a method in the API, it's not clear how you can check if you called it correctly. If you get a return value, well, then you can check that. Or if it changes a property, changes a field in the object, then you can look at that. But if it does something quietly, some side effect in the background that you have no visibility into, that's a problem. So anything that violates these things, if it's not fast, isolated, repeatable, and easy to test, then you should find a way to isolate that, create an abstraction, usually a protocol or something, that you talk to instead of talking directly to the thing. And that's really the key trick to making things easy to unit test.
Yeah. I mean, once all those properties are satisfied, then I guess it's much easier to sell to the team and to yourself that it's worth the investment and easier to spread the word. During the prep part of the call, we mentioned TDD as a practice. And you mentioned that right now, part of your work is to spread that practice and help people adopt it. Can you maybe share a bit on that?
I think there's a misconception by a lot of the tech community in general that TDD just means writing your unit tests first. And it's much more than that. In particular, for me, the key entry point, sort of the thing that made me test infected, was the ability to refactor. And refactoring is another thing that I think the tech community widely misunderstands. Is people think it means I'm just changing things or I'm adding a feature. No, it really needs to be moving in small, verified steps, getting that feedback as fast as you can about the correctness of a thing. What TDD does is that it builds that in to the three-step cycle so that it actually changes how you code. Instead of coding a bunch of stuff, you end up moving in smaller steps than you can imagine. And Kent Beck, who came up with test-driven development, has taken it even further with TCR, sort of, it's like TDD to the max. It's a crazy idea where if you run your tests and the tests fail, it reverts your code. Like it does a reset hard head and throws everything away. And it just sounds crazy. But the reason he fell in love with this is that it forced him, who is, of course, the TDD master, to move in even smaller steps than he thought were possible or necessary. So those small steps, that's part of it. The other part of test-driven development that is different than just writing tests at some point is that it's evolutionary. The design changes and shifts as each new test adds a constraint. I think of it in terms of classic, probably made up story about how do you make a statue of a horse from a block of wood? And the answer is you remove everything that's not the horse, right? But how do you do that? You do that in large steps first. You say, well, it has legs. So let's carve out a large chunk underneath that's not going to be legs, and maybe we just end up with a big U shape. Now, that's not a horse, but it is a step towards a horse. And then we remove things. Each test adds a constraint that narrows the scope of what the code does until finally, in a way, the horse emerges.
Yeah. You kind of helped me remember how I got into TDD. And to be honest, I had hard time embracing it before I started doing those katas.
Yeah.
Repeatable, you do the same thing over and over again. I don't know where it exactly comes from, but I guess from Japanese technique of martial skills and so on.
That's right.
Yeah. And one thing that I was amazed with is that I ended up creating solutions with less code when I fully, or let's say to a larger extent, embraced the TDD, which is, as you said, it's driving you to do exactly what is described by a test and not more. And I remember I usually wanted to do more.
That is the habit of programmers. Skillful programmers can code a lot in their heads, and it's very hard for them to say, no, you're going too far. Do that one thing that the test is asking for, and now reshape the code so that it's more expressive and it's less wasteful and it's clean and easy to maintain. And problems of code coverage go away, problems of maintenance go away. It's a great way to work, but I do recommend code katas as a great way to start. I teach people don't start in your real code because it comes with a mess. It also comes with old habits. And part of what we need to do is learn new habits. And so the kata is an exercise where you say, okay, I'm going to code this thing, but I'm going to follow these funny rules. And you might do the same exercise, maybe even with slightly different rules. In the Global Day of Code Retreat, which is a single day where programmers around the world run through an exercise many, many times together. Part of the fun technique of that is to say, okay, now we're going to do it again, but we're going to change the constraints on how we code. For example, maybe it would be like you get points off every time you touch your mouse, for example, to force yourself to try something new, to say, okay, how could I do this with shortcuts and what shortcuts do I need to learn? Or do this again, but you don't get to use any loops. What would that look like? You don't get to use conditionals. What would that look like? It's a fun way to learn. And it's a safe thing because it's outside of your code. You grow, you change, you become a better programmer, and then you bring yourself to your code.
Yeah, what you said is great because you have that safe environment. It's not that you are trying to immediately push some practice into your production code where you're under many constraints. And expectations are high from your team in terms of your speed, in terms of, many other things. I remember when I used to work with more younger developers that when you come to work, when you're fresh, fresh part of your day, take half an hour, and do a cut.
Yeah.
And once you warm up, it's kind of like stretching in the morning, then you start working.
Oh, I like that. That's a great analogy, that you don't jump into the heavy lifting. You do warm-ups to remember, sort of loosen your brain, your fingers, your memory of the practices you want to follow.
And you also set the standard pretty high because in that small environment, you want to achieving a very high level of, how your code looks and works. It's easier. And then hopefully it follows you through the day. Okay, so people can find your book on Pragmatic Programmer. Am I correct?
Yes. Go to pragprog.com and it's there.
We are also going to share the link to the book in our show notes and also to your website. I noticed there are a couple of very interesting things there. Okay, Jon, thank you so much for joining us and hope you had a great time.
Thank you for having me. This is a lot of fun.